Hey everybody, John Nelson with Haas Automation here today to talk to you about Haas Boring Systems. The Haas finished boring tools can produce highly accurate holes with precise locations. Fine adjustments down to 2 microns or 80 millionths of an inch make Haas boring tools one of the best ways to produce precise, tight tolerance holes. These boring systems for milling machines consist of tool holders, one or more extensions if necessary, rough bore heads, and finish bore heads. Each bore head takes cartridges that hold carbide inserts that actually perform the cutting. A few boring heads can take a range of different cartridges to expand the boring range of the head. Collectively, the Haas boring system can bore holes from 20 millimeters or 0.787 inches all the way up to 154.1 millimeters or 6.0669 inches. Connections between the different components need to be very precise to hold such close tolerance. This is why boring heads, extensions, and tool holders have this unique coupling and why one tool holder can't hold all the boring components. Today, I'm going to be cutting bores that are 1.68 inches in diameter, plus 0, minus 5/10. For my friends outside the US, that's 42.672 millimeters, plus 0, minus 0.013 millimeter. To figure out what drill and rough bore tools I need, I'm going to think backwards, starting with the finished diameter. The final diameter is 1.68 inches, and the finished bore insert has a nose radius of 0.0157 inches or 0.4 millimeters. The size of the nose radius is important, and I'll talk a little bit more about that in a few minutes. I want the finish pass depth of cut to be between 50% and 100% of the nose radius size. So, the width of cut will be between 0.0078 and 0.0157 inches. The diameter values are between 0.0157 and 0.0314. This means my rough bore target diameter is between 1.6486 and 1.6643 inches. Our QC department has a ring gauge measuring 1.654, so I'll target that diameter. 82% of the nose radius is 13 thousandths of an inch. This means I need to rough bore to 1 inch 654 thousandths. Rough bore heads are capable of removing up to 10% of the bore diameter. To calculate what the minimum drill size can be, I'll multiply my rough bore size by 0.9. So 1.654 times 0.9 equals 1.4886. I can use a 1.5 inch diameter drill, and that'll be approximately 90.6% of the 1.654 inch diameter. So I'm going to drill 1.5 inches and rough the bore to 1.654. Then I finish the bore with a depth of cut of 13 thousandths, and that gets me to my 1.68 inch final diameter. When you shop on our website for boring tools, click the Boring Systems link on the left-hand side, then select Boring Heads and Cartridges. If you're visiting this page for the first time, check out the technical information on the drop-down menus and the animation video on how the different components go together. Use the filters to zero in on the proper tools. I'll start with the finished bore head and cartridge. First, I apply the cut type filter and check finishing. Next, I use the boring range filter and select the range that has my bore size included. My finished bore is 1.68 inches, so I check this one and that does it. I get the proper finished bore head and cartridge and I add them to my cart. To find the correct roughing tools, I click Clear All Filters, and this time I select Roughing from the cut type. Again, I look at the boring range filter and select the one for my bore size. Coincidentally, this range has my rough bore diameter of 1.654 as the minimum diameter. I don't want to choose this one because I want more adjustability above and below my target rough bore size. When I select it, I'm left with the correct bore head and cartridges, and I add them to my cart. Now I want to point out something in the shopping cart. Notice that the rough boring head has a pilot diameter of 18 millimeters, and the finished boring head has a pilot diameter of 22 millimeters. This means I need a different tool holder for each head. Armed with this information, I go back to the Boring Systems pages and select Boring Holders and Extensions. First, I set the type filter to holder, and then I set the taper filter to CT40. The next filter is connection size, which is the same as pilot diameter. First, I'll filter to 18, and it shows me two options for my rough boring head. I'll select the shorter one and add that to my cart. To get the proper holder for my finished boring head, I'll uncheck 18 in the connection size and select 22 this time. Again, there are two choices, a longer and a shorter tool holder. I only need the short one, so I add that to my cart. If I were boring deep holes, I could use the longer ones or even add extensions, but I don't need them for this job. Remember, all Haas boring heads are coolant through, so if your machine is equipped with the through spindle coolant option, make sure you buy some TSC pull studs. The only thing left is the inserts. From the shopping cart, you click on the finished bore cartridge and it'll take you to the web page for that product. Scroll down and you'll see a section titled Related Products. This is where you'll see all the inserts that fit that cartridge. Use the filters there to help you select the correct insert. We see there are 4 different grades available for this size insert. There are filters down the left-hand side. Primary workpiece material is the best filter for these inserts. I click steel and it gives me the insert that I need, part number 02-0654. Inserts for the rough bore cartridges are more complicated because not only are there different grades, but there are different chip breakers and nose radii. The web pages for each cartridge list all the inserts that fit that cartridge in the Related Products section. And again, there are filters down the left-hand side to help narrow the search. The first filter I'm going to apply is primary workpiece material. I'm cutting 4130 alloy steel, so I select steel. The next filter to apply is chip breaker, but first, a quick note. All of the inserts for our boring tools are turning inserts. You can get a bunch of good information on the different selections for chip breakers by going to the Turning Inserts section of our website and reading the Insert Styles section. Okay, back to the insert filters. Notice there are 3 chip breakers available. The first 2 are HF finishing and HFP finishing positive. We know these are not for us because this is a roughing operation. That leaves us with HMP medium positive. After I select that filter, I'm left with 3 choices. According to the filters, there are 2 grades available and 2 nose radii. I want the larger nose radius for the roughing operation, so I'll select that filter to narrow it down to 2 choices. The available grades are HTP 15 and HTP 25. The description for HTP 25 says, excellent first choice for steel machining, And it's a little tougher than the HTP 15. They're the same price, so I'm going with the 25. My friend Bob Singh made a really cool video about using our filters to find the right tool for the job. We'll put the link in the description below, so be sure to check it out. You just need to add the inserts to your shopping cart, check out, and your tools will be there. Oh look, they're here. Rough bore heads use a twin bore configuration. They use 2 cartridges that each hold a carbide insert. Each cartridge is adjusted individually to the same diameter, producing a 2-flute boring tool. This symmetrical adjustment produces the best concentricity. Rough boring heads produce bored holes that are spot on location and leave a consistent amount of stock, so the finished boring head can produce tight tolerance bores with very accurate location, near perfect roundness, and excellent surface finish. As I mentioned before, rough bore heads can remove up to 10% of a bore diameter. Calculate the minimum drill size before 10% maximum stock removal by multiplying the rough bore diameter by 0.9. Or calculate the maximum rough bore diameter by multiplying the existing hole diameter by 1.1111. Assemble the rough bore heads by installing the pull stud on the holder and then drop the rough bore head on the tool holder and tighten the 2 set screws. To install the cartridges on the rough bore head, remove the locking cap screws and align the pins of the cartridge in the slots of the rough bore head. You'll notice there are serrations to line up the cartridges, and they're free to slide back and forth. You can install the locking cap screws and just tighten them a bit. Now install the inserts on each cartridge and then slightly loosen the locking cap screws. Use the set screws on the side to adjust the cartridges in and out. The graduations on the cartridges are 2 millimeter diameter increments. If you're using inch sizes, simply multiply your inch size by 25.4 to get the metric equivalent. If you want to convert the value on the metric scale to inch, divide the metric value by 25.4 to get the inch equivalent. Don't forget, the graduations are diameter values. You'll want to make sure that each cartridge is set to the same value on the scale. The quickest and simplest way to set boring tools is with the tool presetter. The ability to set the bore diameter and rotate the tool to check the concentricity of each insert gives you confidence when cutting the first bore with a new tool setup. I print out my QR code and bring it to the machine. With the USB dongle for the scanner plugged into the USB port on the control, I open the tool offset page, press Alt to open the tool presetter, tap Tool Scan Wizard, and press F3 to scan and merge the tool data from the tool presetter with the existing information for this tool on the offset table. Now, I scan the QR code and the offset table is updated. The manual way to adjust the rough bore cartridges is with an indicator and a pair of calipers. Use the calipers to measure the diameter and place the tool holder in the machine spindle and set up an indicator to check and adjust the concentricity of each insert. Trust me, it's much easier to perform this operation on a tool presetter. Now it's time to perform a rough boring operation and measure the results. But first, I want to touch on programming a rough boring operation. In my opinion, the best can cycle for rough boring with 2 inserts is G85. This is known as bore in, bore out. The spindle is rotating as the tool feeds into the bore. Once it reaches the end point, the feed direction reverses and continues feeding out of the bore. Some people program rough boring cycles using G81, the drilling can cycle, where the cutter rapids out of the bore. But I believe this is bad for two reasons. First, the tool usually leaves a spiral-shaped swirl mark on the walls of the bore, and this can interfere with bore gauge measurements. The second reason I believe is that this can cause damage to your inserts, especially on hard, tough, or abrasive materials. I was shooting for 1.654 inches plus or minus 1,000 or 42.011 millimeters plus or minus 0.025. Here we can see the results. Finished boring heads assemble onto tool holders or extensions the same way the rough bore heads do. A single finished bore cartridge attaches to the finished bore head and holds one carbide insert. Diameter adjustments on the finished boring head begin with loosening the locking set screw on the side of the finished boring head. This is very important because if you rotate the adjustment dial even a little bit with the locking screw tight, you can damage the adjusting mechanism. The finished boring heads have a gold dial, and the body of the boring head has a vernier scale. The divisions on the gold dial are 0.01 millimeter or 4/10,000ths of an inch, while the divisions on the vernier scale divide the gold dial divisions into smaller increments. Each vernier division is 0.002 millimeters or 2 microns or 80 millionths of an inch. Again, these are diameter adjustment values. To make a positive diameter adjustment and remove more material, rotate the gold dial clockwise. Wherever the dial happens to be, one of the dial divisions will line up with a vernier line. The first vernier division line, the vertical one, and the last division will always line up with gold divisions at the same time. So I think of the vertical division line as 0 and count the other 5. A good rule for stable finished boring is to leave stock for finishing so the depth of cut is between 1/2 and 1 full nose radius of the insert used. When this is the case, cutting forces are generated in the axial direction where the boring tool is strongest. Too little stock produces radial or side cutting forces, increasing the probability of unwanted vibrations. Typically, smaller nose radii will produce more consistent results. The finished boring head is a single flute tool, and it's difficult to measure and set the diameter without a tool presetter. This is a highly recommended piece of equipment if you regularly set up boring tools. Here's how I dial in the bore diameter when I do not have a tool presetter available. I put the finished bore head in the machine spindle and move the boring tool in position above the hole to be bored. I slowly rotate the spindle with my hand and jog the boring tool close to the top of the hole. If the tool is not going to touch the walls of the hole, I adjust the insert out until it looks like it's just going to skim the hole. I tighten the set screw to lock it in place and run the boring cycle. It's always a good idea to use Dykem or magic marker to paint the surface of the hole before you run it. That way you'll be able to verify that the hole has cleaned up 100%. Measure the hole and make your diameter adjustments to get the bore to final size. I always recommend using a G76 can cycle when finished boring. Known as the fine boring can cycle, the spindle rotates while the cutter feeds into the bore. When it reaches the end point, the spindle stops and the cycle will shift the X and or Y axes to clear the tool prior to retracting. If Q is used, setting 27 determines the shift direction. If Q is not specified, the optional I and J values are used to determine the shift direction and distance. I recommend not using Q in this cycle because you may forget that setting 27 even exists and have no control over which direction the tool moves before exiting the bore. Program I and or J on the G76 block for complete control over which direction and how far the tool moves. The spindle stops and orients to tool change position before making its rapid move away from the wall and out of the hole. So, the first thing is to make sure the spindle is oriented to tool change position when loading the finished boring tool in the machine. Do this by performing a tool change before installing your finished bore head. Now you can see which direction the insert points when the spindle is oriented. If the insert points towards 12 o'clock, you need to move Y- to move the insert away from the bore wall. Program J- 10 thousandths or 0.25 millimeters. Using a small amount like this is wise if you move the wrong direction. You may not break your insert. When the insert is pointing towards 12 o'clock, program J-. If the insert points to 6 o'clock, program J+. If the insert points to 3 o'clock, program I-. And if the insert points to 9 o'clock, program I+ to clear the bore. If your insert faces 45 degrees to one of these quadrants, you can program both I and J for the retract move. Okay, I ran the finished bore cycle and got 100% cleanup. I take a measurement, make my adjustments, and now my bore is right on size. Okay, let's do a quick recap. First, calculate your rough bore size based on the nose radius of your finished bore insert. Calculate your drill size by using no less than 90% of the rough bore size. Use filters on the Haas website to zero in on which tool holders, boring heads, cartridges, and inserts are needed for your bore size. Use the Haas tool presetter to make setting up and dialing in boring tools quick and easy. Program rough bore cycles with G85, bore in, bore out, and program finished bore cycles with G76, the fine boring can cycle, for best results. Thanks for watching, and we'll see you next time.